uploaded and broadcasted.
Oh, it's 30. That's it, right?
Yes, it's fine. So just can you see me there? Camera so that you see my advice for frames.
That's like the limits.
And then we go to this side by choosing. See? Okay. Welcome everyone again for the last lecture of today. So it's a pleasure to introduce you Asia Biega. So Asia did a PhD focused on issues of privacy and fairness in search systems. Later, Asia joined Microsoft Research as a postdoctoral researcher in the fairness team. And currently, Asia leads the Responsible Computing Group at the Max Planck Institute for Security and Privacy. Asia's research focus is rooted on principles of responsible computing, bias, fairness, human factors, societal impacts, data governance and ethics, and digital well-being. So something that I find particularly interesting is that Asia aims to support research in other fields beyond computer science. So this is a very interesting aspect of Asia's research. So thank you for being here today.
Thanks so much for the kind introduction. Thank you. Thanks so much for the kind introduction, and thank you everyone for sticking around. I know everybody is super tired by the end of the week, so I'm going to try to keep it lightweight. I'm Asia Biega. Yes. Thank you, Ricardo. As mentioned in the introduction, I am trained as a computer scientist, and up until my postdoc, I did mostly computational work. And during my postdoc, I started broadening my research. I spent my postdoctoral time in a team that was composed of people working on societal aspects of technology and societal impacts of technology, and looking at this from a number of different disciplinary backgrounds. And this is where I learned how to approach solving problems this way, basically merging my computational background with the expertise of people from other fields. So hopefully you'll be able to get a little bit of that through the talk. If not, feel free to ask me a lot of questions, either during the talk or at the end. And I want to start with saying that I'm okay being interrupted, so if you have any questions, please feel free to ask them during the talk. Everybody typically has a slightly different background, so don't be afraid to ask questions when you have any. I am going to be quite fluidly switching between computational, social, and organizational perspectives in this lecture. For the plan, you got a great introduction to some of the issues that I'm going to be covering in this lecture from Ricardo, and also a background in information access systems through the summer school. So I'm just going to very briefly start with talking about why information access systems are socio-technical and not purely technical. I'm going to quickly overview potential negative impacts information access systems might have. We'll briefly cover different mitigation strategies that people in the community have been thinking about. They are going to be both computational and non-computational, more organizational. And finally, my goal for this lecture is to give you a sense for how to approach research in this area and how to think about operationalizing the concepts of responsibility. So what I'm not aiming to do is just to give you a list of fairness metrics and give you a list of fairness interventions that people have proposed so far, because there are actually a lot of great survey articles where you can read exactly that. I'm going to provide links to these surveys at the end of this lecture. All right, so let's briefly start by reminding ourselves what information access systems are. You should know this very well by now, but what I want to highlight here is that when we think about societal impacts, we should think more than just about search systems that rank people. So we should also think about web search engines such as Google or Bing, about search engines on social media, on platforms like Twitter or Facebook, where search engines rank people, but sometimes rank also content that is created by people. We should think about systems such as marketplaces. So this includes, for example, streaming platforms like Spotify or Netflix or other marketplaces, for example, like Uber, where you also get rankings of drivers or the people who are offering their services. We should think about recommender systems that guide us in our educational and cultural choices in terms of the content that we consume. We should think about news recommendations for similarly reasons and also for political reasons, as was yesterday mentioned in one of the lightning talks. And more obviously, we should think about platforms where people are explicitly ranked and recommended, and that includes hiring platforms like LinkedIn, right, where recruiters are looking for potential candidates for the job openings that they have, but also where job seekers are looking for potential jobs. So this is roughly the scope. We should think about societal impacts in information access systems very broadly, instead of just purely thinking about rankings of people. All right, so something that we computer scientists are very often guilty of is thinking about the systems that we're building as purely technical, right? Here's my algorithm, here is my mathematical definition, and I don't have to think about anything that is happening outside of this neat technical box. But this is actually not true. And when we're designing information access systems, we're actually building systems that are deeply embedded in the world and in the reality. So I'm going to pause just for a few seconds so that everybody can think about where you think people are in information access systems before I move on. All right, so here's how I tend to think about information access systems for the purposes of the research that we're doing. We typically think about two different groups of users. So we have users who are consumers, and we have users whom we often call producers. So these are the people who have certain information needs and use information access systems to search for information or get recommended information. And users who are producers are people who provide the content that is being ranked or recommended in these platforms. So what is the typical interaction that happens in the system? The user as consumer typically interacts with the service through a certain interface. The service provider runs an underlying algorithm that ranks or recommends items from an underlying corpus. Through this interaction, what effectively happens is that the service provider mediates the interaction between these two different groups of users. So that's very abstract. What does that mean, for example, in the context of a search system? We have a searcher who issues a query to the service provider runs an underlying ranking mechanism that orders items from a corpus. And in web search, we typically think of these as just documents, but as I mentioned a couple of slides ago, we have to think about the people who are associated with this content. So these are either the people who have contributed the content or people who are depicted in these documents. As a result of this interaction, the content is exposed to the searchers, and searchers can pay attention to the content of the producers. So in a sense, in many of these platforms that I mentioned, the attention effectively becomes a currency on the platform. It's very similar for recommender systems. We have consumers who are interested in getting a recommendation of items from a corpus. These can be some books or movies. A query here typically is implicit or corresponds to a set of user history. So for example, the product or item ratings that the user has generated in the past, sort of this query. We have a recommendation mechanism that effectively exposes the content of consumers, and consumers pay attention to the content generated by the producers. And so this abstract depiction already gives you an idea of where people can be in information access systems, right? Because we have these two different groups of people. But that's not everything. So obviously we get data generated by the consumers. Consumers interact with the system. So the way they're inspecting the results or clicking on the results or watching the movies or anyway consuming the content. Searchers construct queries. Producers create a corpus. But then we also have people who are not explicitly part of the system. So they contribute to building of the system, either as software developers, to algorithm selection, parameter tuning, and data cleaning. So these are all of the choices that are going to impact the way an information access system behaves in practice. And we also have people who provide labels. So these are not explicitly users of the system, but these are people who provide annotations. So tell us what they think is relevant and it's going to be amplified in the system. Just a couple of examples of why we shouldn't think about information access systems are purely technical. It's because people are a part of the process pretty much in every part of the pipeline. So why are information systems socio-technical? Well, they are used by people, producers, and consumers. They learn from user behavior and from explicit feedback. They use people's creations as the underlying corpora. They're created by people, researchers, engineers, designers, PMs, and they impact societal and economic outcomes. So now, because by now we should understand that these systems are embedded in the world. The first thing, as responsible designers of these systems, the first thing we should do is to ask ourselves the question, what are the potential negative impacts of the systems that I'm creating? So let's talk about a couple of different canonical examples of negative impacts that people tend to think about. The first example of a harm that can stem from an information access system is so-called distributional harm. So in this distributional harm, we think of a resource that the system is trying to distribute among the users, either consumers or producers. And the harm stems from unfair or unequitable distribution of that resource. So in the case of producers, we can think of the resource as the exposure they're getting from the searchers. And the reason why such unequitable distribution of the resource is problematic is because that exposure often translates to an actual resource that is offline, right? So exposure is only a proxy that is serving as approximation for what's actually going on in the world. And so that the resource in the real world that can be jobs or income people are getting from being matched on a platform or having their content sold and so on and so forth. When we think about consumers, the distributional harm is that we might be offering service of inequitable quality. So for example, people from different demographic groups might get better or worse access to information. So these are the distributional harms. The second type of harms people typically consider are the representational harms. When we think about representational harms, the first question we should consider is who is being represented in the results. So when we're returning a ranked list of documents, we have to make sure that different demographic groups are equitably represented. This is a typical scenario that is often considered in fair ranking research. The second question of representation is how these groups are actually represented. So instead of thinking, for example, about producers who are associated with a given document, we can think of people or entities who are described in the document. An example here that I think was fixed since it caused this controversy was that one of the largest search engines, whenever people search for a query like CEO, the first result that depicted a woman was a picture of a Barbie doll. So this caused a lot of controversy, has been fixed since then, but this is an example of how problematic depiction of different groups in the results might bring issues for the company that's operating the service. And here it's worth mentioning that this representation, we have to think about representation in various modalities, right? So we might think about how people are represented through the text that describes them or through the images, like in this example above. I think there's a question here.
So if we take the example of the RNA platforms, what about, how can you, what's the representation of groups if you don't know the attributes that you're studying? Because some people on this platform, they don't tell which gender they are, and nowadays you have 7 gender as well. So like, how can you consider that as like measure it or evaluate it?
It's actually a great question, and one of the active research problems people are thinking about in this area. So some people attempt to automatically infer demographic information, but this is problematic for a number of reasons, because this inference will always be imperfect, because you can easily misgender people. So this is an approach that has been criticized a lot, even though a lot of people have attempted to use it in practice. Sometimes you might ask people to essentially opt in to providing this information. So you can, in the EU, you can always ask people to consent to a collection of certain information. So if you go to your user and tell them, look, I think I would be able to give you better results if I knew what your gender was, then maybe some of the users opt in. It hasn't happened too much. So the third solution that I'm going to talk about, it hasn't been applied in the context of information retrieval. I think that would be interesting to do. In the context of classification, people have started looking at how to measure fairness without access to demographic attributes. Basically looking at certain properties of how error is distributed among their examples, and sort of trying to correlate this with say your input data or the demographic information of different data points that you have there. So I guess to summarize, it's an open research question and a hard one. We shouldn't be forgetting about privacy. In the context of search engine, there are issues. There are privacy issues both for consumers and producers. So when we think about privacy in search, I think we typically think about consumers. So search engines collect all of our search queries, all of our interaction information, and because everybody can imagine that this really depicts our life very closely. So they typically know about what our interests are, what we're working on, where we're traveling, so on and so forth. So obviously lots of privacy issues there. This data might reveal many personal details if it's not explicitly there, right, through by matching different patterns with what other users are revealing about themselves. There is the risk of inference of additional information. Perhaps more surprisingly, there are also privacy issues for the producers of content. And some of the work that has looked at this problem focuses on the so-called exposing queries. So people who are being ranked here might be discovered by searchers in sensitive contexts when the searchers issue queries that are, for example, related to diseases or other problematic content, right? So those might be journalists who are looking for examples for their stories, or other people who want to attack others on Twitter because of their political views. So there can be privacy issues for the producers of the content as well. And this is something that I think has been underappreciated compared to the privacy issues for the searchers. Right, obviously, information systems can impact us as individuals in many different ways, because we're often turning to search engines to learn about the world and what's going on. Obviously, the results we're seeing are going to impact our worldview and our beliefs about what is right and what we think is going on in the world. Systems impact user behavior as well, because users turn to the information access systems to get advice, example, in the medical setting, so that we're interested in whether the symptoms we're experiencing are something that we should seek medical advice on in the offline world. Another research area where there can be some problematic individual influences on the users is the zero pre-research and recommendations, so essentially providing people with some information and recommendations without getting any input from them on what they're currently interested in, but just assuming, what is the next thing that they want to learn about. So these are some examples of the individual influence that systems can have on people, but there are also more systemic issues. So search and recommender systems can impact the economy. Right? I mentioned platforms like Uber, where the rankings of the drivers are going to impact how the income on the platform is distributed to different people. They are going to impact politics because before elections, people turn to those systems to learn about the candidates and what they represent, and perhaps to inform their voting decisions. Systems can impact our culture because when we get music or book recommendations, they're going to shape our tastes, and this is especially important like in search and recommendation systems that are designed for younger people. Education is an aspect that we should also be thinking about. If people end up getting disparate quality of the results, this can easily lead to what people call a digital divide, where certain populations are underserved in terms of the quality of information they're receiving. Of course, polarization and social cohesion is also something that has been covered in the previous lecture. And finally, there are values that are embedded in the way we're designing the systems, and this can easily lead to issues of cultural imposition, right? Lots of big tech companies start in the West, saturate the markets, and try to expand. And together with the way they're approaching design, the way they're training their workforce is going to impact how the values are perhaps transferred to other cultures as well. So definitely something to have in mind. So these were some examples of the harms that information access systems can cause, and what are the specific sources of these harms. And this is something that Ricardo has covered in his previous lecture quite a bit. So let's just briefly recap some of these sources, right? So data biases are some of the sources of the problems I mentioned. The data that we're using to train the systems often is not representative of the general population or even of our user population, in case we're sampling, or in case people self-select with what data they offer. Data encodes historical and societal biases. There are some emergent biases when people start using systems in ways that we as designers have not anticipated. We can experience sudden data distribution shifts. This is something that has happened recently when COVID hit, right? The labor market, the distribution of people in the labor market suddenly changed dramatically overnight. And of course, that has an impact on systems that don't retrain overnight over these distribution systems. So also something to have in mind. So if you're interested in learning more about these aspects, here are also some of the resources, and of course, Ricardo's lecture and the article we covered as well. There are some behavioral biases that we should take into account when looking for the sources of harm. There are cognitive interaction biases. As mentioned before, there's this phenomenon of position bias where people pay more attention to certain parts of the ranking or certain parts of the web page. Automation bias, where users assume that items are relevant just because the search engine or recommender system has returned them as a top ranked item. So people very often don't critically examine whether what the system is returning back to them is actually right or relevant. There are different societal biases of the people that create the system or annotate the data that we use. For example, if we collect annotation about the relevance of different job profiles, the social biases of the annotators are going to play a role in terms of what we're getting as an input to the machine learning algorithm later. And sometimes users have a biased behavior themselves. For example, it has been shown that some hiring ranking systems learn from the behavior of women who themselves very often don't inspect the jobs they don't think they're fully qualified for. So the systems can pick up on these sort of internal biases that some people exhibit just because of their social conditioning. If you're interested in learning more about these types of biases, I'm also including a couple of links here in the slide. Evaluation is another source of harm. Think about the objective function or a loss function you design or you select when training an algorithm. All of the choices that we make when designing this function have certain normative assumptions about them. So for example, if we're sampling the data that we select to compute the value of the learning function will mean that we're summing over some errors and not others. So if we have some systematic biases in which users are sampled and which data we use to compute the loss function, we can just discard errors that certain users or populations get. That's related to something, but also the way we design the equation itself, right? So if we decide to square errors, this is going to amplify bigger errors compared to smaller errors, right? And if the distribution of the value of the error correlates with demographic attributes of the users, so this is also going to have a societal consequence. And similarly, when we take an absolute value in our loss function, right? In the context of information access systems, we can decide whether we only care about overrepresentation or underrepresentation as well. And when we decide to take an absolute value, these differences disappear. So it's a normative choice as well. And these are perhaps the most surprising because we think, oh, there are issues with the data, there are issues with user behavior. But this actually means, the math that we're designing can have societal implications as well. Interface designs. That's another example of how we might amplify certain biases in user behavior. Here's an example of a paper that examined Donors Choose, which is a platform where people can post educational projects in the United States. So schools can post educational projects that they want to crowdfund. This can be something, right? They want to buy books for the classroom or they want to fund a school trip. What this paper found when they analyzed the data of the platform is that changes to the interfaces, so the changes to the website's interface led to shifts in the distribution of the funding that went to different types of projects. So to different types of school where you have a bigger fraction or a smaller fraction of students from poor families. And these interface changes were as simple as allowing people to filter projects by topic, or what is not shown here but was added at some point to this web page is a search box that allowed people to search by the location of the school. And so the choice, as simple as adding a search box that allows people to search by a location, allows them to act on their preference to donate to schools that are closer to them, and leads to this kind of rich get richer effect. Particularly in the United States, where schools are funded from the local taxes. So people from richer neighborhoods donate to schools that are in their neighborhood and perhaps are not as much need as perhaps schools in poorer neighborhoods. So interfaces can be a source of harm as well, and even things as simple as adding a search box can have impacts on the distribution of the resources on the platform as well. All right. Experimentation can be a source of harm as well. Platforms often use A/B testing to decide whether they want to go on with the system change. And on platforms where people get opportunities and earn money, your experimentation, selecting someone to be, say, in a treatment group, can lead to them earning more or less money, depending what your intervention does. So before deploying any A/B test, it's important to understand what sort of economic consequences it might have for the people who are included in the experiment. Feedback loops is also something that we have covered in this lecture. We know that people influence systems, but also systems influence people and how they behave and how they interact. So over time, negative impacts might be reinforced and amplified. And surprisingly, over time, the effects of our interventions might be unexpected. This is something that has been studied in the context of classification, perhaps not so much in the IR, but in the context of classification, people have shown that if you're considering an algorithmic intervention over a longer period of time, sometimes the intervention that you think is helping an underrepresented group in, say, one step is actually hurting them long term. It's important to consider these long-term effects as well. These are the harms, and what can we do to fix this? We can think about different responsibility norms. These can be norms that we as society determine are valuable. So through discussions, we decide that this is what the system should do. There are some ethical principles that we could take into account. So think about how other fields have thought about these issues and try to translate that into the computational reality. Some of these social and ethical rules then get codified in different laws. They have been mentioned before as well. So GDPR is the General European Union's General Data Protection Regulation. CCPI is a Privacy Protection Act from California. There are different anti-discrimination laws that govern how people should be treated in labor markets. The European Union is thinking about regulating a number of different areas that includes the AI and digital services like marketplaces and so on and so forth. Just to give you one example, these are the principles that GDPR mandates the systems take into account. So those include lawfulness, fairness, transparency, purpose limitation, data minimization, accuracy, storage limitation, and integrity and confidentiality. And in the area of responsible computing, a lot of research has happened on fairness and transparency, a little bit less in purpose limitation and data minimization. And well, accuracy is something that we generally try to optimize for in the first place, as information trivial researchers and other computational researchers. All right, so say the ethical principles or social norms or the law tells us our systems should be fair. But what does that mean? What does it mean to operationalize fairness? And I think now we are at a stage where we design a number of different algorithmic interventions, assuming that fairness metrics exist. But where do these fairness metrics actually come from? How should we think about designing them? All right, so think for a second. So we have a system. This means the algorithms, the data, the users, and then we have a very abstract concept like fairness. So what to do about it? How to go about connecting the two? And there are some strategies we can take. So people have come up with a number of questions that we can ask ourselves to design these types of metrics. So I would like to tell you a little bit how one might approach thinking about this. So when you think about operationalizing very abstract concepts like fairness, typically the first thing we have to do is to come up with a definition. This is our goal. What is fair? And that definition is not yet enough. For example, to evaluate systems or compare systems. So from the definition of that goal, we have to go to the measure. So the measure tells us how far are we from this goal that we would like to achieve. Once we have that, we can design interventions. So how do we actually achieve this goal in practice? At the beginning, when people got interested in algorithmic fairness, a lot of work has happened here on this side. Because we didn't even know what fairness might mean. Now, after a couple of years, a lot of groundwork has happened. So we have a number of different definitions. So I think research in this part of the picture has slowed down a little bit, and people are now thinking hard about how to design these algorithmic interventions. How can we actually achieve fairness, given that we have to take so many different things into account? The data, the algorithms, the way people interact with systems. All right, so we have to start with a definition. How to do this? I know Ricardo showed you a paper from the 1970s, and actually one of the fairness definition facts that people use in the field is also inspired by some of the concepts that people thought about in the 1970s. So this is a paper from a psychology journal called New Directions in Equity Research. So basically here, they explain what they mean about equity. And equity is one of these concepts of fairness that people in other fields have thought about, right? That in certain cases, you might think of fairness as equity. And so basically what they say is that in an equitable state, when you have a number of people, there should be some proportionality between the outcomes different people have and certain inputs they provide. So this is still very abstract. And now the most interesting question in this research is, okay, so how do I translate that in my system? Right, so I have a search engine and I have to think about some outcomes and some inputs and some proportionality. So typically the first thing that people do when coming up with new definitions is exactly this, trying to provide some translations. All right, but before we get there, before we're able to, we can translate what outcomes and the inputs might be, we have to ask ourselves, whom should we be fair for? And in other words, who are the relevant stakeholders? So we can think about,
Can we go back to the previous slide? So this definition, there's nothing that depicts the richness that A or B have, right? So my input may be very small, but it may be 50% of everything I have, while the other one, 50%, maybe just 1% of everything I have. So there are definitions, how to account that.
Right. Yeah. So as I mentioned, this is just one concept of equity, and I think there was a very nice picture in the previous lecture that showed the differences between fairness, equity, and justice.
Yeah.
So we definitely can think of a number of different definitions, and typically what happens is that we start from these different normative assumptions of what we want to achieve, and then we try to translate all of them separately.
It seems that it's almost a societal definition of what the society wants. Taxes are not the same for everyone. There's a increase
Yeah.
Most countries.
Yeah, for sure. And I really resonated with also what Ricardo said, that our job as computer scientists not to come up with the definitions of what fairness should be. And we should talk to people who have thought about this before, so say economists or lawyers, or people who really have domain expertise in a given field. And our job is to do this. Right? Talk to them, understand really what is here, and then say, oh, I think in the context of the search engine, the outcome could correspond to the ranking position or the exposure that people get, and I think the inputs might correspond to relevance. So this is something we're qualified to do as computer scientists. We're qualified then to create interventions that try to implement these things in practice. And then what we also shouldn't forget to do is to analyze what effect these interventions have, what are their limits, what are their characteristics and properties, and offer that insights back to the domain experts so that this process can be refined over time. All right, so when coming up with the fairness definition, we have to think about the relevant stakeholders. There are different groups of people that we should consider. So these can be consumers, searchers, the producers of the content that we have on the platform, but also the people who are depicted in the results. The second question is, when you, for example, think about distributional fairness, and this is the typical fairness definition that people try to operationalize in IR. That means we want to fairly distribute a resource. What are the kinds of resources that we could consider in an information access system? So for consumers, we could think about the quality of the service and say, I want different stakeholders to get results of equitable quality. For producers, we can think of equitable exposure. And for entities, so people who are described in the results, we can think about fair coverage, or think about this more linguistically, right? So that different groups are depicted with a similar sentiment and so on and so forth. So there are different types of resources that we can think about when designing the fairness metric. How do we measure that? So now that we know roughly what resource we want to distribute. So when we think about consumers and the quality of service, we can just use established IR or recommender systems metrics that are typically used to evaluate the quality of the results. For producers, when we decide that the exposure is the resource that we want to distribute, we can measure it, for example, through click probabilities. So what is the probability that people click and inspect results of different ranking positions? We can measure inspection time, either through eye tracking or using or measuring how long people have a certain part of the web page on their display, and so on and so forth. And for this, we can use and establish user browsing models. And again, this is one of the most interesting questions that people are considering here when they're designing interventions, is which browsing models should we be using? So of course, when research in this area started, people assumed the simplest browsing models. So they assume exponential decay over ranking positions. That's a good thing to do. Like, we should always start simple because we need to get insights into what this problem even is in the first place. And once we have that understanding, then we can go more complex. So account for not only the position bias, but also the presentation bias, different societal biases. So have more complex models for how people are browsing so that we can get a better estimate of the resource that we're trying to distribute. And here a quick note on proxies. The resource that we're going to select is typically only a proxy. So this is not an actual resource that we care about. Often the exposure, say, in an HR platform would be a proxy for getting a job or getting contacted by the recruiter. In a marketplace, that would be a proxy for getting customers and earning money. And why do we resort to these types of proxies? Typically, we do that for two reasons. Either because the real construct that we're interested in is really hard to measure. So if our resource, so if we talk, for example, about say merit, what would that even mean to measure merit of people that we are ranking, right? This is a construct that is inherently hard to capture, so we always have to select a certain proxy. And sometimes we just don't have access to the right data on the platform. So an HR platform might know that the recruiter contacted the person, but they might not have the information that the person is actually later hired. So we have to resort to a proxy as sort of the best thing that we can get our hands on. And whenever we're working with proxies, and this is pretty much the case always in this area, it's important to investigate the reliability and validity of these proxies. So to what extent what we're actually measuring is capturing our intended construct, and what are the caveats, what are the limits of the proxy that we have selected. And this is often a point of frustration that people have when working in this area, because they say, oh, the construct I'm selecting is actually not measuring this and not measuring that. It will always be the case with proxies. What is important to do is to understand the limits and document them and be very transparent. If you're interested in learning more about measurement, this is a great paper to look at measurement and fairness. All right, we're almost there when it comes to the definition. So now we can come up with different definitions or different goals for what fairness might actually mean. We can decide to go for parity. So we want to distribute the resource equally. We can decide to distribute the resource proportionately. For example, in proportion to the presence of different groups in the corpus. So we might say, well, if my corpus is 60% women and 40% men, then I want to distribute 60% of the resource I have to women and 40% to men, right? So in proportion to their presence in the corpus. Or we can say, I want to distribute this in proportion to people's relevance to a given query. People who are twice as relevant should get twice as much exposure as others. So this is how we can think about the fairness goal. And finally, we have to decide on the granularity. So we can think about individual fairness, being fair to every individual in our system, in our corpus, or we can think about group fairness. In group fairness, groups are typically defined by certain socially salient attributes. So it's going to be gender or ethnicity. And the reason why we might want to, we care about these fairness definitions is sometimes the anti-discrimination law tells us what your system shouldn't discriminate against populations that were historically minoritized or discriminated. Sometimes groups can be defined also by business needs. For example, producers of different popularity might need some boost in exposure because of the biases that have been mentioned before, and sort of rich get richer effects that we want to break, and so on and so forth. The groups can be defined in different ways. All right, so these are the components of the fairness goal. But the fairness goal tells us only, this is the ideal case. This is what I would like to have in my system. But this is still not a measure, right? So we need to come up with a measure that would allow us to understand how far we are from achieving the goal and to be able to compare different systems. So here, as this is a screenshot taken from this paper, for example, if we determine that what we want to distribute is the presence of different groups in different ranking positions, what we can do is to compare the presence that is defined by the fairness goal. So for example, we say, I want equal representation of two different groups in different ranking positions, and compare that to what we actually can measure, what is actually happening in the system. Right, so the observed quantity measures what's actually happening. And so how many ranking positions up until K are occupied by members of a group G. And then, as I mentioned before, there are different ways in which we can compare the goal and what's actually happening in the system. And each of these different metrics are going to have different properties and amplify or cancel certain errors. So don't pick this without giving it some thought for what's actually important in your setting. All right, and I'd like to also tell you what are some of the biggest pain points currently when it comes to fairness measurement, because all of the metrics sound great in theory, but are really difficult to measure in practice. And there are three such issues. As mentioned before, group membership annotations are either limited or missing. And this is something that pretty much all of the group fairness metrics need. So the question is, how do we get that? And there have been a number of different approaches in the recent literature. I mentioned some of them in response to my answer before. But when it comes to, say, system evaluations, what people attempt to do is, for example, try to evaluate results with limited annotations. So sample the data to annotate. This can still be problematic because getting these annotations, it's problematic for privacy or ethical reasons. So no good answers there. If any of you are interested in working on this, I think it's one of the biggest pain points currently in this area. The second thing is that some of the fairness metrics require this notion of input, right? So I should get some outcome in proportion to my input. And fairness metrics typically assume that relevance would be the sort of input that quantifies how much resource I should get in return. But it's unclear how to get that in practice. So in some settings, it might be that these are some say user ratings that we could use as a description of how much resource somebody should get in a given setting. Of course, these are biased as well because users who provide these ratings are biased. sometimes we might assume that the system is computing the relevance score for you, and that might be true for some systems, but not for others. For example, most learning to rank algorithms try to create good orderings of items, but they don't intend to actually come up with a relevance score that is well calibrated. And this sort of calibration is important to make sure that this can be used in a fairness metric. So unclear how to get these merit scores so that this proportionality based on relevance can be actually computed. And finally, accurate estimate of exposure. There have been a number of papers recently published at ESSIR2022 that look at this issue in particular and try to push our understanding of how complex the exposure models should be in the fairness context. So I think these are some of the three most interesting questions currently in this area. All right, so we covered this part so far. We have a fairness goal, a definition. We saw how we can measure how far we are from that goal and use the metrics to compare different outcomes. What about the interventions? Typically here we think about algorithmic interventions. There are three classes of interventions that people typically think about. Pre-processing approaches aim at fixing issues with the data. So for example, if your corpus is unbalanced, then perhaps you can add data about members of underrepresented groups. I am not aware of a lot of work in IR that focuses on this pre-processing part. In-processing approaches aim at modifying the algorithm itself. So a typical approach, for example, in the context of learning to rank algorithms, would do something like this, right? You have part of your loss function in the learning to rank algorithm that focuses on accuracy, so that's the sort of vanilla component, and then you add some regularization factor that accounts, for example, for equalizing the exposure of different groups. This is one of the papers that takes this approach if you're interested. Most of the work that has happened in this area focuses on post-processing approaches, where you get a certain ranking from your IR or from the recommender system, and you try to change the ranking to satisfy different constraints or different fairness definitions. Typically what happens is that you sacrifice the overall accuracy of the ranking a little bit to get to something that's more equitable. An interesting thing that I want to mention here is that, or an interesting feature of this problem, especially as compared to algorithmic fairness and classification, is that for some fairness definitions, it makes sense. It doesn't make sense to think about the static single ranking. Right. So for a static single ranking, we can easily achieve notions such as the diversity of presence of different members of our underrepresented group, because then we can basically intertwine their presence in different ranking positions. But when we think about metrics that look at proportionality of exposure, a ranking like this is actually optimal in terms of this relevance proportional fairness metric, right? Because when we rank people who are more relevant at the top, they're going to get sort of the relevance that gets them the closest to that fairness goal. The intervention or the limits of the fairness that we can achieve this way, the fairness that we can achieve this way is quite limited. So instead, what different approaches in this area have done is look at sequences of rankings to improve a little bit of this limit of what we can do. There are two types of approaches to this. Either look at sequences of rankings and try to amortize fairness metrics over time, or construct ranking distributions and sample rankings from your distribution, so that in expectation you can achieve rankings that maximize your fairness metric, but subject to certain constraints on utility. So these are the two types of approaches that people have taken in this area. So why do you think that is? Why shouldn't we think about a single ranking, but actually either amortize or think about fairness and expectation? The reason for this is that when we think about these metrics of proportionality, when we say users should get attention or exposure that is proportional to their relevance, these distributions are never going to be the same. So the distribution of relevance over the user population and the distribution of attention or exposure of the user population are pretty much never going to be the same. The reason for this is that factors that influence this distribution are very different from the factors that influence this distribution. So here, this can be the query, this can be the data that we have in our corpus, and so on and so forth. And here, there are a lot of human factors that influence this. There are the biases, interaction biases, cognitive biases, the position bias. So this is the reason why it makes sense to think about this over time instead of in a single ranking instance. All right, so these were the algorithmic interventions. I mentioned this briefly before, but when I talked about how interface designs can contribute to harm on the platforms, but we can turn this around, right? And use interface design as an intervention. So if we have a certain fairness goal, so for example, on the charity donation platform, we say, well, we want more donations to go to schools with a bigger proportion of students from families of high poverty. What we can try to do is to, add some interface elements and measure how that impacts the distribution of donations and see whether that gets us closer to our fairness goal. So that's another option for how we might approach intervening on fairness. And finally, what happens in practice is that fairness is only one of the goals that we might have, and different stakeholders in the system might have different interests that are sometimes competing with each other. So we have consumers, we have producers, we have service providers, advertisers, regulators, and even just the first groups of users, consumers and producers. The fairness metrics that we discussed, the fairness needs that they have are very different, right? They might conflict with each other. So how do we approach this in practice? Computationally, what we can do is to try to capture all of them separately and then try to optimize them jointly. One of the approaches that one may take, but there are perhaps also some organizational approaches, not only computational ones. For example, have different groups of stakeholders negotiate in terms of what they would be willing to give up and what they must get from a platform. All right, at this point, I would like to briefly switch to another responsibility norm, or in this case, one of the GDPR requirements. And this part is going to be shorter, so don't worry, I'm not going to keep you here beyond the lecture time. So let's talk a little bit about operationalizing data minimization. Data minimization is a requirement that is specified in GDPR, and here's how it's specified. Personal data shall be adequate, relevant, and limited to what is necessary in relation to the purposes for which they are processed. So again, maybe you can recall that slide earlier on when we said, well, here's my abstract concept of fairness, and here's my system. What do I do? Exactly the same situation, right? We have this very abstract legal requirement, and we have a system. And as computer scientists, we need a specific mathematical definition and a way of achieving this. Before we talk about this, a little bit more background on what data minimization is and why we might even want to, why it's a desirable property. So data minimization is related to privacy, but it's in many ways broader. It's a more general risk management framework on the platform. Data minimization allows us to avoid unnecessary risks of personalized data processing. It allows the service providers to think whether they actually need the data that they're collecting. And of course, the data that is not necessarily poses the risks, but it's not used for anything productive. So why store it in the first place? We might prevent service providers from inferring additional personal information about us. So it's not explicitly there in the data, but can be inferred in conjunction with the patterns of behavior and data of other users. By minimizing the data the platform collects about the users, we give users increased control over the data, more agency, and better understanding of what's going on and what data about them is out there and available. And more on a more societal level, we're limiting the possibility for surveillance and targeting. So there are many reasons why we might want to implement the principle of data minimization in our systems. This principle has not been uncontroversial. Actually, we collaborated with a colleague from law to try to uncover the real reasons why this principle has been controversial. And some of the reasons that have been mentioned is that, well, we're going to curb innovation. So whatever company has to operate in markets that need to minimize the data won't be able to gain as many insights as companies that are not limited by this principle. In some cases, we might be limiting technology that is actually societally desirable. So search engines sometimes implemented, say, disease prediction systems based on people's queries, right, that allow us to quickly spot disease hotspots. So some of the tech might be desirable. We might not be able to do it if we only limit the data to what we actually need at the given moment. Well, we might be limiting the competitiveness of the European economy or any company that is operating purely in this market. And finally, one of the reasons that this principle has been controversial is that a lot of people believe that we just cannot implement it anymore. Right? That we live in a world of big data, and our algorithms need all of this data to provide quality service. And for me, as a computer scientist in particular, that last argument is interesting and something that I wanted to investigate deeper. I'm sure many of you in many different settings have stumbled upon this fact that many algorithms exhibit the diminishing returns property. So as we collect more and more data, at the beginning, perhaps we're able to improve the service, but at some point we reach this plateau, right? So the quality of the algorithm is not changing anymore. And we have found examples like this in a number of different papers. This is a paper from 2008 that looked at the quality of personalized search, how personalized search gets better as we collect additional features about the users. And this diminishing return property is exactly what you can observe here, right? That at some point, it pretty much we're not gaining anything by collecting new data anymore. So we found some empirical evidence that we might not need all of the data that we're collecting. We found another paper focusing on deep learning that actually found that data collection exhibits, so algorithms exhibit 3 different stages of performance as we collect more data. We have a small data region where the results are just bad, so we need more data so that the algorithm can actually learn the underlying distribution. Then we are in a power law region where we're trading more data for increased performance. And finally, we have this irreducible error region. And from the perspective of data minimization, this is the most problematic. Well, what do we need this data for? Right. So we have empirical evidence that we might not need all of this data. And we actually also have a number of computational techniques that could be readily implemented to achieve data minimization. So techniques like feature selection or outlier detection or active learning were not developed for the legal principle of data minimization, but in practice do minimize data, even though we do this to increase the quality of the models or limit the storage costs or limit the annotation costs and so on and so forth. We have empirical evidence, we have computational techniques, and what are the real obstacles to adoption then? What we found is that there are very few guidelines. So as you said at the beginning, the principle itself is very abstract, and in practice, people have a hard time interpreting how to translate that into specific definitions or into specific algorithms. We found some studies, user studies with software developers, have shown that in practice, developers have a very different understanding of what data minimization might mean when they have to implement it in their day-to-day practice. So there is a lack of guidelines. There is a lack of operational definitions in the context of data-driven systems, say personalization, profiling, and other decision-making systems. We found some guidelines by data protection authorities in Norway and the UK that typically either don't talk about data-driven systems at all. So they would talk about individual attributes like gender or location and say, well, in this particular context, it doesn't make sense to use the location. And in this other context, perhaps could be justified. But what to do about data-driven systems that collect observational data? All right, so our clicks, our ratings, and so on and so forth. Some of these guidelines, when they talk about data-driven systems, they typically mention techniques, but without specifying how these techniques should be applied in practice. So they would say something like, you should investigate the learning curve of your algorithm, right? But what does it mean to actually investigate, and what should I do, and should I stop collecting the data? So that's a little bit of a background for what data minimization is and why it might be desirable, and what might be the real obstacles. And one of the obstacles is that we don't really know how to operationalize this. So let's go back to the definition and let's figure out what we need to understand to be able to operationalize this. So two keywords that are interesting here for the purpose of this lecture is that data has to be limited and necessary in relation to a specific purpose for data collection. So when we have a definition like this, what are some of the questions we should be asking ourselves? First, to be able to limit data in relation to the purpose, we have to decide, we have to specify what the purpose of personal data collection is in the first place. Once we have that, we can figure out what it means to limit data in relation to that purpose. And finally, as I mentioned, it's important to, once we operationalize our construct and create our algorithms, it's important to offer back the insights back to the community that is thinking about these problems from a different perspective. So let's understand what are the trade-offs and consequences of data minimization according to these interpretations, so that they can decide whether it actually makes sense to implement them this way. Right, so for the first question, so when you think about recommender systems or search engines or other personalized services, what is the purpose of the data collection? An important thing to realize here was that in personalization, personal data is collected not necessarily to deliver, but to improve a service. Right? When I have a search engine or recommender system, I can offer people random results or random recommendations. Or I can provide recommendations that are based on some data that I collect off the platform. So in case of movie recommendations, I can use cinema ticket sales statistics to use popularity as a factor for recommendation. So we don't need this data to provide the service. The reason we do this is because, say, random results or results based on other data sources wouldn't be very good. Right? We want to tailor them to a particular user. So once we realize this, then we can propose this definition. So let's tie the processing purpose to improvements in performance metrics. So once we have that interpretation, we can think about specific mathematical definitions. And here are two papers that have proposed some of these specific definitions. So in one line of work, there were two definitions called global data minimization and per user data minimization. What the global data minimization definition said is that we should limit the data, say collect only key items from a user profile, subject to a certain threshold on the loss in the global model performance. And global here means that we're looking at the model performance as aggregated over all of the users. But we can also think about per user data minimization, where we say, I want to limit the amount of data I'm collecting. So say I want to limit it to key items from the profiles for each user, but subject to a threshold on the loss for each individual user. These are just two alternatives, none is better than the other. And a recent paper, in fact, 2022, proposed a definition that looks at performance curves and looks at the derivative of these performance curves and says, well, once the slope becomes too flat, that means we're just not gaining so much in terms of the model performance. Let's stop. Let's put a threshold. So these are the three recent definitions for what data minimization might mean in mathematical and algorithmic terms. And I want to mention here, coming back to the third question I mentioned is important to investigate, like what would be the impacts in case we're implementing or in case we're interpreting a certain responsibility principle in this or that way. One of the interesting results from this FACT 2022 paper is that when we think about this performance curve slope definition of data minimization, and we say, well, we want to stop once that that curve becomes too flat, and we're using active learning techniques to query users for their data as we train the algorithm, as we collect the data. We found is that if you take some of the off-the-shelf active learning algorithms to do that, we're going to end up with a very unequal distribution of data collected from different users. What does that mean is that we have a number of users from whom we're collecting, say, 600 items, 600 pieces of data, and we have some users from whom we're collecting only a few. And there are a lot of interesting questions that we have to ask them. Like, should the users have the right to decide whether they want to be these high collection users and perhaps pay with their data and increased risks for the quality of the service for the others? So lots of interesting questions here. And the final thing when it comes to data minimization I want to mention is that when you're designing a responsible system, it's important to think about different responsibility concepts at the same time. Thinking about fairness in isolation, or thinking about accuracy in isolation, or thinking about transparency in isolation is not enough, because the solutions you're going to develop for one are going to impact the other. And just to give you one example here is that, well, people have worked a lot on fairness and people have worked a lot on accuracy, and sort of this interaction between accuracy and fairness is something that people have tried to understand before. What is the trade-off between the two? Some of the work I talked about before thinks about data minimization versus accuracy. So if we're collecting less data, are we going to get services of lower quality? But then since, for example, GDPR does not impose a hierarchy of these principles, we have to try to achieve them all at the same time to the extent possible. So an interesting question here is, what is the trade-off between data minimization and fairness? And some of the papers I mentioned on the previous slides found that, well, there might be quality of service impact on individuals and groups. So when we minimize the data, some of the groups might pay for, in terms of the loss of the quality of service more than others. What I showed on one of the previous slides, we might have disparate burden of data collection for certain individuals and for certain groups. And this is something that we have to consider as well, and possibly get consent from users to be high collection users. And finally, there is also a paper published in 2022 that found that data minimization might actually create an obstacle to fairness audits. When we're minimizing attributes such as gender, location, or other attributes that are used in the fairness metrics, it might make it impossible to audit for fairness, and deciding where to find the sweet spot is an interesting question as well. So I want to end with a final intervention or non-intervention. So we talked about how to fix the issues, but this is sort of a natural instinct that we as computer scientists have, that we always have to come up with a computational solution to everything. But it's important to, in certain cases, ask ourselves if the computational intervention is what is even being asked for. Sometimes it's worth taking a step back and deciding that not designing systems is what we should be doing in the first place. And I want to point you to this paper from Kai 2007 that asked a number of these different questions. So could the technology be replaced by an equally viable, low-tech, non-technological approach to the situation? Does a technological intervention result in more trouble or harm than the situation it's meant to address? And does the technology solve a computationally tractable transformation of a problem rather than the problem itself. And this is related both to the proxies I've discussed, but it's also related to the fact that very often we're solving the problems that we have the data for, that are easy to solve in this way because we have the infrastructure available, instead of solving the problems that actually need solving. So I want to mention this as non-design as a final intervention that we should be thinking about. And with this, I'd like to end the lecture and take your questions. Thank you.
Question there. Yes. Thank you for your presentation. This that gets like various interventions. Is that what we define very narrow proxy for what's we're trying to solve, and then we use this proxy to zero. And it's just taking account down the roads next. What do you feel about this? Do you agree with this?
Yeah, this is a hard question, and I think this is an argument people often use to like discredit this line of work, where they say, well, you're never going to solve the problem. Why do you bother? And I think progress in this area can also be incremental. So as we figure out what are even the fairness goals that we should care about, and what are the ways to achieve this, we can improve the situation bit by bit, right? And this to me, this is a value as well. So this is how we think about this. There's value to doing incremental work without revolution.
Two questions. First one is, when you talked about the groups in fairness, always on like mention one attributes, or is there some work where you consider several attributes like race, gender, and locality, for example? Just focusing on one attribute right now.
Most of the work focuses on one attribute. The reason for this being is that this is we should start simple, right? And this is the simplest case that we can try to solve and understand. Now that we have a good understanding of what interventions for fairness for a single attribute might be, some people have started thinking about defining multiple attributes. So say jointly optimizing for gender and race. If you're interested in the social sciences, there's this theory of intersectionality that thinks about every person has an identity that is comprised of a number of different dimensions. And this is an active topic of concern in the fact community, which is an interdisciplinary community thinking about these issues from different disciplinary perspectives. And there was a panel that this year at the conference that discussed intersectionality as one of the issues. How do we find the relevant dimensions of a person's identity that we should account for in designing fairness interventions, and when to stop, right? Because of course this is pretty much infinite in some ways. So this is a hard problem. There are solutions to propose, but
and my second question is regarding to exposure ratios. So in the example, we always see one document associated with one provider. But like, what about documents where you have several providers, for example, scientific papers where you have several authors? Do you consider one author like as a principal investigator, or do you distribute the exposure among the authors?
I think this would have to be adapted to a particular setting. So I don't think there will be one answer for this. We stumbled upon this. So I organized a track for a ranking track in the first year. So track is a benchmarking conference in the information to the community, to those of you who don't know. So the fair ranking track has been running for I think 3 or 4 years now. And it started with scholar research. We run into this issue that papers have multiple authors. And you can have different approaches. So, for example, you might try to bin the authors into, say, seniority, according to the H index or the number of papers they have published, and try to think about exposure for members of these different bins. In some cases, you have to think about what your intervention, what is the problem that your intervention is trying to solve. So in some cases, we might want to give extra exposure to papers that come from institutions or from countries that are underrepresented in science, and then we might, for example, compute the average over all of the authors. Let's say how many papers this institution has published in top conferences and so on. So this might be one approach. In other cases, you might want to give extra exposure to junior researchers. And so that's a different normative goal for what kind of intervention we'll be trying to solve. And in this case, perhaps it would make sense to look at the most junior author of all of the authors. But I think it really depends on what is the problem that we're trying to solve.
So we were talking about the minimizing data story of data. So thinking about like big companies and like there is reports about that somebody will post important data that one company knows about and on the big trend. Even though that the company is sort of like one company, but like you are tracking different things and reports and stuff like that. It's amazing to know about all these systems, but at the end of the day, hired by these companies, maybe or something like that. But there is no rule that prevents companies from collecting all this data that are oriented and say, I don't know that, what is our role? Because like, if you remember like, when Mark Zuckerberg was accused of having like Cambridge Analytica, so the doctor or like people who were asking him, they had little information about how the internet works. And so I think like there is so much should be done from governments. Right. So what's our role maybe? Should we, if we were hired, that we, I don't know what change we should do. What's your thoughts about all this?
It's exactly the right problem you're thinking about. And the way, so my personal opinion is that no individual approach is ever going to solve the issue. So we shouldn't just focus on algorithmic interventions or policy interventions or education. We have to do all of these things at the same time and hope that each of them is going to amplify different aspects of the problem and perhaps help other interventions work, have more impact. So an example of policy that helps with the issue mentioned, right? That people don't know what data is being collected. That here in Europe, GDPR also requires that people consent to collection of their data. So you typically get a pop-up when you visit the web page where you have to agree to the collection of your location, cookies, and individually. Of course, no one reads this. There are lots of usability issues related to consent. So this is also an active research area for how to do this better. But yeah, this is an example of how policy can help. Forcing service providers to actually tell and transparently tell users what data they're collecting for what purposes. Education is another important aspect, that people actually have an understanding of how internet works. I'm certainly right that this is a limitation. I stumbled upon a report by a UK NGO a couple of years ago that conducted phone interviews with users to try to understand how they think the internet works and what they understand about what's going on. And I can't remember the exact numbers, over 50% of the users were not even aware that search engines collect their queries, collect and store their queries. Right? In this sense, it's hard to try to enforce your own personal rights to data minimization when you're not even aware that certain data is collected and stored. So education is an important aspect there as well. We as engineers can definitely, when you go work for these companies, as to try to advocate for these responsibility principles and try to apply them in your day-to-day practice, and also teach others in your technological environments about the importance of thinking about these issues. So we can approach this from a different approaches. None of these individual solutions is going to solve the problem.
This is problematic to infer things like gender or race for users. And at the moment, I'm trying to work on intersectional issues in academic data, and one of the ways I came up with to find variable values for gender and race is just infer the names alone. So I was wondering, would you still consider it problematic on that minute level, not just on like a behavioral level, as in for gender from names, for example?
Whenever, I think it's important to be transparent about the limitations of an approach like this. There are certain names that are unisex, or and in this case, the algorithm is going to make certain assumptions about who that person is. There are certain issues for trans people, for example, whenever there is information about them, their dead name. So there are issues like that for this particular disadvantaged population. We might have more data about names in Western cultures or names in English, and then have fewer data for names from other countries. And then the algorithm is going to make more errors for people who come from these areas. This is especially important if you're actually for immigrants to other countries. So you're making a prediction for a given country that we have people coming from abroad whose names might not be recognized as easily. So there are a number of different issues to consider as well in terms of gender from names.
Maybe I do not have a question, but a suggestion. In your presentation, you use the word stakeholder. You define this term by example. I would suggest to consider this literature definition, because what is important in the stakeholder, the stake. What is the stake? And the stake, I think that it is great that this person would like to achieve a lot of positive benefits, and of course have the very low risk of anything, of activity and so on. So maybe in this approach, the learning, this awareness would use this term stake. I mean, somehow measure the benefits and the risk which is connected. Because for me, the definition by example, the stakeholders is not suitable. Better maybe business actors or something like that. Because usually in the system we have, like, for example, actors. When we are designing the system, we are talking about the actors. We are users of actors. Okay. So the stakeholders term is more specific, and I would suggest to consider this concept stake. This is the first suggestion. The second concerns the resources. And for me, resources, and I think that is something what we have. So this, we can talk about human resources, information resources, physical resources, financial resources, and so on and so on. But here in your presentation, you also do not have, I would say, good definition of this resource. Maybe when you consider the resources assets, whatever asset could be, informational assets also, it would be more precisely, because this term, like, you think that the quality of service, for me, it is not a resource, but it is my opinion. So I would suggest to study this issue deeply and then propose maybe using other terms.
Thank you for your comments. I agree with your observations about risks and benefits. What I want to mention here is these are not the terms that I made up. These are the terms that are actually used in the communities. So of course, if we decide to rename these things, we should do this as a community. But yeah, thank you for the suggestions.
Thanks for the presentation. I have a question in regards to, say, a model, for example, has been built in the US for the American community, and then this product works fine there since there are not a lot of data information. But the same product is about to be marketed to the European community, for example, where now you have GDPR and all of those restrictions. What are your thoughts on how this could be managed, since you can't just bring the same products directly from European markets because of those regulations.
That's right. This is a complex issue, I think. So sometimes it might actually work well in that you can train your model on the data of the population that does not fall under some of these regulations. So, for example, data migration, you can use all of the data of people who are in the US and then just ship the products in the EU. The tricky part there is that, of course, populations in different countries exhibit differences in how they behave, how they interact with products. So there may be some cultural biases that are embedded in sort of this implementation of a given product that's trained in one market and transferred to another. So the availability of the data and these cultural issues, and perhaps what I mentioned in part earlier in the lecture, is transfer of values that is implicit in the technological designs. It's an issue when thinking about different markets as well. So I would think about these three aspects. Could we actually reuse the models and data, and does it actually help us? Is that fair to this population that's it's not as protected as the population for whom we're transferring the product? So that's one aspect. The second aspect is the differences in data shifts and distribution shifts is that covered and accounted for, and the cultural imposition values we're embedding in this. It's a hard question.
So I was interested in your talk about feedback loops or runaway feedback. And I've spoken to someone before who works in bias and to do more so in a political lecture. And their solution to like these runaway feedback loops are to have like nudging, like gradual nudging of users towards diverse opinion. I was wondering, would you consider that also a potential solution for like fairness issues, like nudging people? And then in that kind of increasing focus for someone's someone who's like someone's class is like as a not useful resulting system. So some like a long ongoing process of discrimination over generation.
This is an interesting direction. So I'm thinking of the two relevant thoughts. I'm not sure if they're going to answer your question directly, but let's see. So first is that in one of the papers I mentioned, right, in the sort of interface interventions, you can think about them as nudges, right? Because when you add a certain element of the design, you're going to nudge the person towards selecting this item or that item from the ranking, or it's going to make it easier or more difficult to search for certain types of items. So these interface designs, different elements of interface design can be thought of as nudges. What we found as part of the study was that we conducted an active experiment on a crowdsourcing platform where people were exposed to two different groups of workers were exposed to different versions of the same website. The original website and the website with sort of nudge intervention, so one element changed. And at the exit interview, we asked people to tell us how they decided. So the goal of the workers was to select projects for fun. We asked them what drove your decision? What were the aspects of the project that you considered? And for some of the nudges, there's one nudge where we simply, in the ranking list, we showed people whether a given school has a high proportion of those students. Once we showed them this information explicitly in the form of a nudge, more people mentioned that this is something that helped them make a decision. So this is perhaps it's somewhat related to your question, and that the people realize, oh, this is even a consideration in this platform, right? It's not something I had thought about before, and maybe I should be fair, right, and give more to poor schools. So in this sense, I think that could help.
Thank you. What did you another part of the answer?
Yeah, I'm thinking, yes, there was another paper that I think is somewhat relevant to your question that looked at whether famous interventions actually help. Because what we're doing, I mentioned some of these post-processing interventions when we change the order of the items that are being displayed, and we're assuming that this, we're done. But you always have a person that is in the end interacting with the given system, and the way they select the items in the end is going to determine whether we're actually getting to the distributions of the resources and the assets that we desire, that normatively we have decided this, right? And I think there were 2 papers that have shown that this might not necessarily be the case. That people very often override this ranking, and perhaps if they have a very strong societal bias against certain demographic groups, they will still go down the ranking and just omit the results that don't fit their preconceptions about who is relevant and qualified.
Is there a way to find that picture? I'll ask about that.
Yeah, maybe I can include the link later. Just let me take a note of this in the slides.
One of the slides you mentioned that from a survey it was saying subset as have a different understanding of what data minimization is compared to researchers. Do you possibly remember what was said their understanding of what data minimization is?
Yeah, so some of the people, for example, considered data minimization at different life stages of an algorithm. So should we minimize the data when we collect the data? Should we minimize the data when we store it, or when we revisit periodically whether we need it? So people have different ideas about when this should happen in sort of the life cycle of the project. People had different conceptions about what are the algorithmic approaches that one might take to data minimization. Some people thought about that anonymization of the data is a technique that checks off the data minimization requirement. And in some sense it does, because of course anonymized data can be linked to individuals anymore. If anonymization is perfect, and it never is, so eventually it doesn't solve the problem. Data stops being personal, right? So if we're not dealing with personal data anymore, then GDPR doesn't. If we don't have to take these principles into account, right? For non-personal data. Of course, in practice, we won't be able to anonymize data to that extent. But yes, anonymization is one of the techniques that people have considered for the implementation of data minimization. So going sort of in the direction of the solutions. Right, some of the other techniques I mentioned, like active learning, feature selection, outlier detections, these sort of data cleaning techniques. But there are no unified patterns as of yet. So it will be interesting to see more work in this area where people propose new solutions and see what they do in practice.
Okay, so let's thank the speaker. Thank you. So, just one final note. So tomorrow will be in lecture theater B1, not B3. So it's 2 or 3 floors below. Okay, so we will have to change lecture theaters.